So, presentation. Yeah, one second.
Function your
Yeah, yeah. Can you hear now?
Yes.
Okay.
Okay, good morning, everybody, and welcome to this session named EMEWE. This morning's session, we have 5 contributions, and I leave the floor to the first one. I'm the chair of this session with Maria Cereta, Professor Maria Cereta, that is coming now. And I leave the floor to the first contribution of the day, that is the Urban One Health approach for the planning of the effective intervention on territory, a systematic analysis of the scientific literature by Pierluigi Morano, Felicia Di Liddo, Marco Locurcio, Francesca Fariello, and Deborah Nelli. I leave the floor to Francesca Fariello. Thank you.
So, good morning, everyone. My name is Francesca Fariello, and today I will be presenting a research project carried out in collaboration with the Politecnico of Bari and Sapienza University of Rome, entitled The Urban One Health Approach for the Planning of Effective Interventions on Territory, a systematic analysis of the scientific literature. So this is the index of the presentation. And the aim of this work is to define an analytical framework based on the main components of the Urban One Health approach, as discussed in the current scientific literature. In particular, the study seeks is to analyze the scientific contributions that have addressed the Urban One Health approach, to define an analytical framework around its core principles and applications, and to examine how this approach can support the strategic management of urban transformation. Urban One Health is increasingly recognized as a holistic and interdisciplinary model for city planning. It proposes an integrated vision of health, one that connects human, animals, and environmental dimensions, and positions health as a key element of urban sustainability. The analysis also aims to identify interdisciplinary tools, methods, and best practice emerging from the literature to promote the integration of public health, environmental sustainability, and urban planning practice, and ultimately to contribute to development of holistic, resilient, and inclusive cities. This work is based on the assumption that the urban One Health approach is not only a theoretical construct, but a practical framework that can guide policy and planning processes. By addressing the current global challenges, such as climate change, socio-economic inequalities, and the disparities in access to resources, the approach may support the implementation of effective and inclusive urban strategies. So, the Urban One Health approach is framed within the broader global debate on sustainable development, climate adaptation, and urban resilience. It emerges as a response to the critical challenges posed by rapid urbanization and increasing environmental and health pressure on cities. At the global level, international organizations have officially recognized the need for coordinated action to manage health risks, the boundaries between human, animal, and environmental domains. The Urban One Health model addresses the interdependence of these dimensions by promoting a multidisciplinary integration of urban planning, public health, ecology, and governance. It provides systematic strategies capable of responding to urbanization's trends and environmental pressure through comprehensive and holistic planning solutions. The One Health framework encourages collaboration across institutions, disciplines, and sectors, including researchers, local authorities, public agencies, and private stakeholders. Such cooperation is crucial to addressing complex issues such as the spread of zoonotic diseases, environmental degradation, and urban health inequalities. But several critical challenges remains. Among the most pressing are sectoral fragmentation, limited citizen awareness, and high initial costs associated with the implementation. This factor can significantly slow down the operational transition toward a One Health-based urban model. In light of these challenges, the objective becomes not only to build resilient ecosystems, but to ensure that cities are also inclusive, sustainable, and equitable. The methodology followed in this study began with the identification of a set of keywords represented of the main themes linked to the Urban One Health approach. Such as urban One Health, urban sustainability, environmental health, etc. Using these keywords, a systematic search was carried out on the main academic database, for example, Scopus and Google Scholar, which led to the initial collection of 187 papers. At the second stage, a filtering process was conducted to assess.
Excuse me for interrupting. We need to open the remote session.
To share the screen. Can I help you?
Ah, sì. Che è successo?
Si vede.
Come mai non si vede?
Si vede. This one, yeah. No worry. Okay, thank you.
Okay,
Okay.
sorry.
No, don't worry. At the second stage, a filtering process was conducted to assess the thematic relevance and scientific consistency of each contribution. Only the studies that explicitly address the interrelational between human, environmental, and animal health within urban context, and that adopted an interdisciplinary perspective were retained. As a result, a final set of 57 papers was selected for in-depth review. Each of these contributions was then classified and analyzed according to three main dimensions, as illustrated in the diagram shown in this slide. Research objectives is the first and referring to the specific goals of each paper, such as the development of theoretical frameworks, the proposal of new planning tools, or the analysis of health outcomes in urban environment. Then the context of analysis, including the geographical setting and thematic focuses examined in the studies, for example, pollution, exposure, green space accessibility, etc. And the methodological approaches referring to the techniques used, which range from systematic reviews and empirical modeling to the application of GIS tools, environmental indicators, and health impact assessment. This classification made it possible to structure the analysis of the literature and to identify recurring trends, methodological patterns, and area of governance or divergence across the selected contribution. The first set of results concerned research objectives. In general terms, all contributions emphasize the strategic importance of integrating the Urban One approach into urban planning processes. The most frequently observed objective relates to the analysis of the relationship between the urban environmental and public health. This includes a broad spectrum of factors such as air and noise pollution, urban density, access to green areas, or in this perspective, the literature confirms that environmental determinants are keywords to understanding and addressing health inequalities within cities. Accordingly, many studies propose integrated urban strategies as a way to improve community well-being and promote equitable and sustainability development. Recent research also highlights the growing importance of local governance in shaping urban health policies. The role of evaluation tools, particularly the health impact assessment, is frequently underlined as these instruments support informed decision-making processes based on the significant evidence. Another emerging objective concerns the synergic integration of urban planning, public health, and ecology. As a result, the Urban One Health approach is increasingly being framed as an operational strategy for promoting not only healthier urban environments, but also more inclusive and adaptive cities. The second level of analysis concerns the context addressed. Several recurring themes emerge, each representing a specific articulation of the broader Urban One Health paradigm. One of the most frequently discussed issues is the relationship between access to green space and mental health. Many studies examine how limited access to nature within urban areas can lead to increased level of stress, anxiety, and other mental health disorders, especially among vulnerable groups. Closely related to this is the analysis of urban pollution and its impact on human health. Factors such as air and soil pollution, noise exposure, and urban heat island are widely investigated for their role in increasing chronic diseases, particularly cardiovascular and respiratory conditions. The third level is these approaches reflect the multidisciplinary nature of the topic involving urban planning, epidemiology, environmental sciences, and public health. The first and most widespread approach consists of systematic literature review. These are employed to provide a structured overview for this debate, identify the theoretical models, and propose practical tools to support policy making. Systematic reviews also help define common research trends and emerging priorities. A second group of studies is based on quantitative and empirical analysis using datasets from environmental monitoring, epidemiology, and socioeconomic sources. The use of statistical modeling, machine learning, and big data analytics increasingly common, especially in studies that link air pollution and urban from to health outcomes. Another relevant methodological block includes the use of a geographic information system. These tools are applied to map risk factors, explore spatial inequalities, and support scenario-based planning. Combined with the remote sensing technologies, they allow researchers to monitor urban changes and their impacts on the health in real time. Several contributions also adopt experimental approaches such as pilot projects and intervention-based studies. These include low emission zones, green infrastructure prototypes, and nature-based urban design experiments. Some papers even test behavior responses to the new urban condition, for example, the introduction of walkable areas or green corridors. A particular important focus is on indicators used to assist the health of the urban ecosystem. These include environmental, social, and economic indicators, which together offer a multidimensional view of urban well-being and are used to evaluate the effectiveness of planning intervention. In conclusion, the literature review confirms that the Urban One Health approach represents a holistic and multidisciplinary model for understanding and managing urban environments. The integration of public health into urban planning emerges as a key element to improve quality of life and addresses complex challenges such as climate change, pollution, socio-spatial inequalities, and environmental degradation. The reviewed study suggests that city design with health in mind through green infrastructure, sustainability, mobility, inclusive governance, and access to service can become more resilient, equitable, and sustainability. As for future developments, the Urban One Health perspective suggests several promising directions. That is, first, the need to systematically integrate health criteria into urban policies and planning regulations, overcoming the current sectoral and fragmented approach. Second, the promotion of interdisciplinary training programs for urban planners, public health professionals, and policymakers. Third, the development of participatory tools that actively involve communities in the co-design of welfare urban environments, reinforcing the social dimension or sustainability. Finally, the consolidation of international networks and the local pilot project as seen in the case studies analyzed, can support the diffusion of best practices and encourage innovation in urban governance. Overall, the Urban One Health framework proves to be not only a valuable lens for analyzing the city, but also a strategic and operational model for guiding urban regeneration in line with the goals of equity, resilience, and collective well-being. Thank you for the attention.
Thank you very much for your presentation and also to respect the 15 minutes perfectly. I'm asking to the public also online if are there any questions about this contribution? No questions? Online? So I'm just was questions. I just was wondering. Uh, First of all, congratulations for your presentation. It's very clear, and also the issues of health and health impact assessment is very relevant for managing the transition of the cities and the challenges the cities are going to afford. And I just was wondering, you mentioned the systematic literature review that you had you will made to collect all these issues and produce the other results. But I was wondering which type of selection criteria to produce the systematic literature review are you able to introduce in order to expand the results that you obtain now?
Yes, I research these themes on the literature review, and so I conduct this research to explain how it is and what is the to develop this.
No, I just was wondering if you have set some keywords, specific
Yes.
keywords, because
I
seen
showed
the
this.
presentation,
Okay.
Okay,
Sustainability.
okay. The main keywords to
Yes.
produce this literature.
One Health, general, and so urban One Health.
Okay. And it could be interesting to expand this literature review also producing a protocol that contain more keywords connected to the
Project.
yes, also to the theme of well-being that is very connected to the health problems.
Yeah, to improve these other models, for example.
Excellent.
Okay.
If no other questions, comments, okay, we can go on.
Yes.
Okay. Okay. The second contribution of today is urban green spaces and housing prices, the impact of metric choice on econometric models. And the authors are Pierluigi Morano, Deborah Nelli, Francesca Fariello, Marco Lucurcio, and Felicia De Liddo. I leave again the floor to Francesca for this presentation.
Yes. Okay. So now I will be presenting a research project carried out in collaboration with the professors Pierluigi Morano, Deborah Nelli, Marco Locurcio, and Felicia De Liddo, entitled Urban Green Spaces and Housing Prices, the Impact of Metric Choice of Econometric Models. So the aim of this work is to analyze how the choice of green space metrics affect the outcomes of econometric models estimating housing prices. To achieve this goal, a case study has been developed focused on the city of Rome. This urban context has been selected because Rome is one of the greenest European capitals in terms of total urban surface. A multilinear regression model has been applied to a georeference dataset related to the territory of Rome. The green space variable uses three distinctive metrics: the absolute surface area measured in square meters, GSM, the percentage incidence of green space over the total territorial surface of each urban zone, GSI, the presence or absence of green areas encoding as a binary variable, GSD. By comparing the regression results obtained using each of these metrics, the study assesses which one offers the highest explanatory power and which most effectively captures the real influence of green spaces on housing. In order to introduce our work, it is important to start from a key premise. Urban green is today considered a strategic infrastructure for the contemporary city. It not only improves air quality and biodiversity, but also contributes to psycho and physical well-being and social cohesion. However, when we analyze its impact on real estate value, things get more complex. As the slide above shows, the scientific literatures tell us green can have very different effects on the market. That is, in some cases, it drives up prices, in others, it has no impact, and sometimes it can even be perceived negatively. For example, when it is neglected, isolated, or insecure. This variability led us to reflect on an often overlooked but central point for quantitative analysis. How is green measured within econometric model? Our work starts from the idea that the choice of metric with which we represent greenness is not neutral. May condition the results of the model, the significance of the variables, and so also the interpretation of urban policies. We therefore developed a comparative approach applying three different metrics of urban greenness to the same regression model: the absolute surface area in square meter, the percentage incidence on the total area, and a simply binary variable presence and absence of the green. This allows us to assess how much and how the effect of green changes depending on how it is measured. And it also allows us to ask a broader question. How reliable are the models we use in urban areas if just changing our metric changes their conclusions? It is from this theoretical framework that our case study, which I will now present, takes shape. So, having defined the theoretical framework and the reason for our methodological choice, let us now enter the case study and the dataset used to apply this comparative model. As anticipated, we have chosen to work on the city of Rome, a particularly interesting context for two reasons. Rome is one of the European capitals with the largest area of urban green. Over 30% of the city is covered by parks, historic villas, river strips, and ecological corridors. And second, at the same time, it has a strong urban inhomogeneity, with the neighborhoods that vary enormously in social, environmental, and real estate characteristics. This makes it an ideal laboratory to test how much the measurement of green can affect property value estimates in such a fragmented context. We therefore collected data for 117 homogeneous urban zones, as defined by the Revenue Agency, excluding areas with predominantly industrial use or few market data. For each zone, we constructed a geo-reference dataset in which, in addition to the green variable, we include the urban and socio-economic context indicators, which now I will illustrate. Okay. The model we used is a multiple linear regression. It is a well-established technique in urban economics because it allows us to estimate the effect of each independent variable on price while keeping all the others under control. The structure of the model is always the same. We only change the green metric to assess how its form of representation affect the results. All variables have been standardized and the dataset has been tested to avoid multicollinearity or bias. This allows us to make a direct comparison between the three models and answer to our initial question: which measure of green most effectively reflects its real impact of house value? So let us now turn to the results. In the first model, we represented the urban granary using the absolute surface area in square meter denoted GSM. This metric simply considers how much green area there is in each urban zone without taking into account the proportion in relation to the territory or its distribution. Overall, the model has a good explanatory power with an R-square of about 0.8734. However, if we look specifically at the variable green, we see that it is not statistically significant. The p-value is 0.385, well above the conventional thresholds. What does this mean? That in this case, the absolute amount of the green does not have a clear or stable effect on house prices. Probably the housing market does not simply respond to the amount of green, but to how this is distributed or perceived. In the second model, we use a different metric, that is the percentage incidence of green on the total area of the zone. This metric considers not only how much green there is, but how relevant it is to sites of the area. It is a more balanced way to compare urban areas of different sizes. The result here improved R-square is higher at 0.8751 and the p-value drops to 0.138. Although we are still now not below the threshold of classical statistical significance, this variable comes close to becoming significant. In other words, the proportion of green is a greater impact on prices than the absolute quantity. This suggests then the market responds better to the ratio of green to urban space rather than to square meters percent. In the third model, we use an even simpler approach, a binary variable called GSD, which only indicates whether there is or is not green in an area. This type of metric is very synthetic, but completely loses information on the amount or distribution of green. The model itself remains robust with an R-square of 0.8746, but the GSD variable is not significant. The p-value is 0.186. This tells us that the presence of granary alone, without additional information, is not sufficient to explain price variations. The housing market is more sensitive to the quality and proportion of green, not to the simply is there or isn't there. So we have seen the results of the three models. We can compare them directly. As the slides show, all three models have a good level of statistical reliability, with R-squared always above 0.87. But what really changes in the behavior of the green variable depending on how it is represented? Let us look at the comparison. The model we presented, that is the percentage of the green on the area surface, it's one with the best overall performance. It has the highest R-squared value and the lowest p-value, 0.138. Close to the significance threshold. This suggests a potentially real relationship between proportionate green and property value. The model with GSD, the binary variable presence absence, performs somewhat less well. Its simplicity penalizes the ability to capture important nuances. The model with GSM based on the absolute quantity of green is the less effective. R squared lower and p-value very high confirm that the mere quantity does not say much about the perceived value of green. This comparison reinforced the idea that metrics matter and that in urban models a proportional representation of the green is more consistent with the logic of the market and perception of the inhabitants. So, this study offers us two main messages. The first is methodological, that is, the metric chosen to represent urban green has an influence on the results of economic models. It is not a technical detail, it is an analytic and political choice which can guide the urban strategies, investments, and public interventions. The second message concerns interpretation. Green is not an objective fact that always has the same effect. Its value depends on where it is located, how it is distributed, and how it is experienced by people. This invites us to design smarter and more sensitive models that do not just count trees, but take into account qualitative and perceptual dimensions of urban green. For the future, we are considering a number of directions for further development. Include qualitative indicators such as maintenance, accessibility, and perceived safety. Testing the model on other cities with different morphologies and cultures, and introducing machine learning tools or spatial models for more dynamic and predictive analysis. In conclusion, we hope that this work can contribute to a more critical, sensitive, and operational reading of the role of the green in the contemporary city. Thank you for your attention.
Thank you very much. Are there any questions?
Yes, I
Please.
was wondering what was the timeline of the data set that you considered? Because maybe there was a difference before and after the pandemic, so you noted some changes in needs for urban spaces, urban green spaces for the communities, and if the pandemic had had an influence on the housing crisis. So the timeline that
This work is to do in 2024, so after pandemic, yes.
so you couldn't notice some changes and after the COVID-19, but it was a curiosity. So thank you so
Okay.
much.
Any other questions? Also for online people?
Mm.
Okay.
Maybe I can have one.
Yeah.
I came in late, so I don't know if you tackled
Okay.
the question. But I don't know. But I was wondering, like, does private green has an effect on the perception of green spaces and how green the city is? In the sense, like, if you go maybe in a neighbor where everyone just put like some plants in the balcony, there's another perception of the city.
Mhm.
I was wondering, like, does this have an effect on how you perceive spaces?
The effect of the green
Yeah.
in
Like the perception of green in the cities, like is it just like the public, the one that the municipality take care and make available for the citizens, or does have an impact also the one that autonomously decided to?
no all impact.
All impact.
Yes,
Okay.
the perceived.
Okay. Thank you very much. Okay, we can proceed with the next presentation titled The Implementation of Multi-Criteria Analysis for Heritage Assets Enhancement and Application for the HBU Identification of a Historical Building in an Italian Municipality. The contribution is by Marco Locurcio, Felicia Di Liddo, Laura Tatulli, Pierluigi Morano, and Deborah Nelli. I leave the floor to Laura Tatulli for her presentation. Thank you.
Did you share your screen? Oh, I'm sorry. I thought it was keep it going. The third, yeah. Entire screen, yes? Or just a selected tab? The window. The first, the second, yes? No. I'm sorry, I'm a bit clumsy. Sorry, it's okay. Don't worry. On this screen or the slideshow? Which one? No, it's fine like this. Okay, the notes. Okay, thank you. So, good morning to everyone, and thank you for having me here. This work was made by Marco Locurcio, Felicia Delito, myself, Pierluigi Morano, and Deborah Anelli. This presentation is about the implementation of multi-criteria analysis for heritage asset enhancement. In particular, we will focus on an application for the HB, the highest and best use identification of an historical building in an Italian municipality. So this is how this presentation we will develop. We will see the aims of the work, the framework of the topic, the methodological approach proposed, the case study. In particular, we will focus on the evaluation criteria and their weights, the functional or proposing alternatives and their importance, the identification of the highest and best use, the results analysis, and in the end, the conclusions and the future insights. So the central role of historical and touristic assets has led the public administration to seek for adequate and efficient strategies to manage and use this kind of assets. In particular, in order to have the preservation and the conservation and the financial sustainability of this kind of heritage building, is important to consider the possibility to implement a refunctionalization project. To this end, appropriate instruments are required to identify the best alternatives, and so the highest and best use among different potential uses, considering simultaneously specific predetermined criteria. It is important to highlight that when we say the best alternatives or the highest and best use, we do not refer to an alternative or a potential use that is the best in absolute terms, but we want to refer to a condition of balance in order to satisfy in the best possible way different criteria. So, multi-criteria decision analysis is an adequate tool for this purpose because it allows one to consider both different aspects in a simultaneous way. And the aim of this research concerns the application of this kind of method to a case study relating to a functional or proposing project for an historical building which is located in a municipality in the south of Italy. So, the several challenges that are surely associated with the management of heritage assets and repurposing project come from primarily from their peculiar specificities and the need to define, identify interventions and projects that are able to generate positive impacts in social, economic, and environmental terms. They also have to ensure financial sustainability in order to even guarantee the protection of these kind of assets. And so the MCDA technique allow to consider these different aspects, translating them in quantitative criteria, such as those linked to the expectation of revenues and profitability, and the qualitative ones. There are those considered like the surrounding context or the compatibility with the socioeconomic tissue in which the project will take place. The different kind of techniques are based on the different phases. In particular, for this case study, we adapted two techniques combined, which are the analytic hierarchy process, so the AHP, and the technique for orders of preferences by similarity to ideal solutions. And the use of this technique combined was developed by the definition of the goal, the construction of the criteria matrix, the determination of the local weights of each criteria, the normalization and elaboration of the alternative matrix, the computation of the global weights, and the aggregation of the weights for the identification of the best alternatives. So the two techniques combined for this work allow the first one to determine the weight of each criterion based on the preferences of the decision maker. For this study, the DMs are the technical office of the local public administration. This technique is based on the concept of criteria pairwise comparing in order to determine the respective weights and among alternatives for each criterion to establish their relative importance. The final result is obtained by the aggregation of the weights of the criteria considered and the scores assigned to each alternative through the WSM approach. So the HP was combined with the TOPSC, sorry. And so this technique enables the calculation of distances from the ideal solutions and the similarity coefficients through the decision matrix and the data normalization process. This technique is based on the concept that the best solution is characterized by the minimum distance from the best solutions and the farthest distance from the anti-ideal solutions. It generates 4 different orders, which are depending on the type of the applied normalization and which approach was used to identify the ideal and anti-ideal solutions. So the integration of these two techniques combined ensure a structured and balanced approach that facilitates the decision-making process, combining subjective approaches with the analytical one. So the case study concerned an historical building located in a municipality in southern Italy, and nowadays, the building first floor is currently used as a library, while not all the surface is actually used, and only few rooms, which are the largest, are occasionally used for conferences and meetings, mainly by the public administrations. And in consideration of a series of restoration and consolidation intervention that are needed to guarantee the structurally the structural functionality of the building. The object of this work is to identify the highest and best use for this property, starting from a set of reproposing alternatives that were suggested by local population, professional association, and representatives of the public entities. So these are the evaluation criteria that were considered. We have the net income, which is considered and defined as the difference between the total revenues that are expected by the implementation of the alternative analyzed, and the cost necessary to all the expenses necessary to have the reconversation intervention. The riskiness, which was assessed only qualitatively in terms of likelihood of not achieving the expected net income through a comparison of the intervention with similar ones within the same area. The structural compatibility is defined as the impact of the new proposal, new use on the structural elements and on the bare loading capacity of the building. The compatibility with historical and artistic features of the building was included to consider the impacts of the new use on the parts of the asset which have historical and cultural value. Then the compatibility with the surrounding context was a criteria that considered how the new project is integrated in the tissue, the urban tissue, considering both accessibility to the building itself and the presence in the area of other buildings or spaces with similar functions. The alignment with the interests of the location of the local population, also the locals, is a criteria that allow to consider the impact of on the residents and on the local population of the project. Those are the weights identified for the different criteria considered, and the most influential one is the structural compatibility. That is so because in the DM's opinion, the need to preserve and guarantee the conservation of the building was fundamental in order to have the implementation of any of the alternatives considered. Then the secondly most important influent criteria is the compatibility with historical and artistic features. The others were considered as less relevant, but they have a specific weights themselves. The consistency ratio, it is particularly low. In fact, it is equal to 2.9%, is a good result. In fact, indicates adherence with the transitivity principle, and so the coherence of the judgments and the care with which the DM carry out the comparison. These are the functional reproposing alternatives. So the different use considered for the building were the use of the spaces as conference rooms, which is so the implementation of spaces to host events organized by public or private entities, and they were designed to be subjected to a payment of an hour fee. And this alternative includes the promotion through social media channels or press review. The use of the building for art exhibition spaces was designed for temporary displays by emerging contemporary artists, and it was imagined to provide some additional services, such as the promotion of the event through posters and social media challenges, or even the guaranteeing the management of lighting where applicable. The use of the spaces for co-working was designed to support the startups, professional firms, and the companies, and the service fee includes costs for cleaning and different utilities. The alternative use for the building, like a restaurant or a cafeteria, was including some different transformation in order to provide all the technical supported and systems needed for this implementation. Then we considered the use as is, which is the non-intervention alternative scenario, which entails the continuation of the current function. This is the criteria and alternative evaluation, which was based on the attribution of scores from 0 to 10 for each alternative respect to the criteria before that we have seen before. And we can notice, for example, how the conference room was considered highly compatible from a structural point of view, as well as the use as is, while the restaurant cafeteria option was considered as really not really compatible with historical and artistic features, since the transformation needed for this use. So the analysis conducted allow us to identification of the highest and best used, and in particular this was possible thanks to the determination of the synthetic numerical indicator, which is the Topsis closeness coefficient. And the coefficients were obtained for each of the 4 different orders, which are depending on the type of applied normalizations and the approach used to identify the ideal and anti-ideal solutions. And this analysis takes us to consider that the highest best use corresponds in 3 out of 4 cases to the use of the building for co-working spaces, while the restaurant cafeteria option ranks as the least favorable. These are the orders and the calculation. And then we conducted the results analysis, in particular the combination of the AHP and the Topsis techniques as after a structured and balanced decision-making approach, and this implementation has enhanced the consistency and the reliability of the results. It is important to highlight, though, some limitations, which derives mostly from the subjectivity of the judgments expressed by the DMs. Even though there are these limitations, they are partially overcome by the involvement of several stakeholders, so the considerations of several points of views, the use of the consistency index, and the normalization of the data, which is typical of the Topsis method. This is the correlation matrix that was developed to ensure the independence of the criteria used. And this matrix has highlighted how there are some high positive relations between some of the criteria, which has led to considered that the provided information were not sufficiently independent. Then the other limitation, as we said before, is the intrinsic subjectivity of this kind of approaches, which may introduce some bias. So for the future development, we imagine a more refined differentiation, reformulation, merging, or reconstructing of these criteria in order to reduce the redundancy and improve the consistency of the DM choices. And the quantitative definition of less subjective criteria and indicators that can be taken from other academic works with similar purposes. Thank you all for attention.
Thank you very much. Are there any questions from the public? Please.
I would like to know which kind of stakeholders do you consider on your study?
So there was the public part that was made up by the technical office, and so the public administration that is usually really involved in this kind of projects, because these kind of heritage assets are mostly belong to the government, also the public administrations, while private investors are a main have a crucial role for their financial contribution. So these considered were the one linked to each of the alternatives. So for the implementation of co-working spaces were considered private, companies or professionals associations. Sorry. I don't know if I answered your question.
Any local representation, citizen representation?
I think it is possible in general to integrate this kind of contribution. Yes.
Okay, thank you.
No, you're welcome.
Any other questions? Okay. Thank you.
Thank you. It is mine.
No, probably this one. Okay. We can go to the third presentation of the day. That is by Benedetto Manganelli, Francesco Tajani, Pier Francesco De Paola, and Francesco Paolo Del Giudice. The title of the presentation is Quantify the Priceless, a Methodological Approach to the Evaluation of Historical Architectural Heritage. I leave the floor to Francesco Paolo Del Giudice, please.
Prima ok, devo solamente qua e questa qua, ok, e dopodiché ok, questo qua. Okay, perfect. Good morning to everyone. I'm Francesco Paolo Del Giudice, and the work is entitled Quantifying the Priceless, a Methodological Approach to the Evaluation of Historical and Architectural Heritage. The work was...
You didn't share your screen.
I think he's sharing. I'm not sure.
I don't know.
Sorry. No, it's not.
Ah, it's not.
Aveva ragione. Okay. Okay, thank you very much. And the work was carried out in collaboration with Professors Benedetto Manganelli, Francesco Tajani, and Pier Francesco De Paola. The aim of the study is the historical and architectural heritage of Italian series as a resource to be preserved for future generation. And this research analyzed the impact of the historical and architectural component on property value, with specific regard to property used for tourism and for hospitality, with specific regard to the city of Rome. The adopted methodology integrates two approaches: the AHP, analytic hierarchy process, with the multiple linear regression models, allowing consideration of both qualitative and quantitative variables in the real estate valuation. Why is it important to evaluate a real estate property with historical and architectural component? Because can be performed for purpose of purchase and sale transaction, or for damage compensation claims, expropriation proceedings, and estate divisions. In literature, the impact of the historical and architectural component on property value has been examined from both an intrinsic point of view and extrinsic point of view. In intrinsic point of view, in terms of the way that this variable assumes relative to the value of the single properties, and an extrinsic point of view in terms that the positive or negative externalities that neighbors designated as historic produce on the value properties located within them. And we have that in an intrinsic perspective, we have an increase of real estate market due to the presence of the historical and architectural component on the 22% in Boston and Cambridge.
Sorry, could you switch off the microphone from home, please? Thank you.
Thank you very much. And an extrinsic point of view, we have an increase like the 58% in Louisville in Kentucky. The work is structured into three phases. We have the first phase with the formation of the estimation sample, and with the formation of the valuation sample consisting of 13 historic hotels and the comparable assets. And after, with a direct monoparametric valuation method, we determine the value of an individual hotel room for the historic hotel and for the comparable asset. In the second phase, we draft in the questionnaire. So there is a creation of a questionnaire for industry experts with the evaluation of the 13 historic hotel properties based on 4 criteria defined according to the literature. And after, we have the weighting of the 4 criteria with the AHP, analytic hierarchy process. In the third and last phase, we have the application of econometric analysis with specific regard to the hedonic price method for the determination of the marginal price, the marginal contribution of the historical and architectural component on property value, with the statistical analysis and interpretation of the results. In the first phase, so we have the formation of the estimation sample that consists of 13 properties for tourist accommodation use located in the center of Rome, and designated as historic by Federalberghi Roma. And for each historic properties under study, we select comparable units in a variable number 1 to 7, according to 4 comparison characteristics: productive, intrinsic locational, extrinsic locational, and technological. And after, with a direct monoparametric method, the market value of the individual hotel room for the historic and for the comparable assets was calculated. And it can be observed that the value of the historic hotel room is in all cases higher than the value of comparable assets, room of the hotel assets. And this is precisely due to the presence of the historical and architectural component. In the second phase, we, at this point, drafting the questionnaire. So industry experts are asked to evaluate the data sample under study consisting of the 13 properties, historic properties, and according to the 4 criteria. The 4 criteria are the historical and artistic significance, that is a criterion related to the historical and artistic value of the building, and this may due to its architecture or interior design, connection to the historical events or famous guests who have stayed there. The architect, that is a criterion related to the prestige of the architect who designed and or oversaw the construction of the building. Preservation of the original appearance, that is criterion related to the preservation of the building's original appearance. And cultural importance, that is criterion related to the integration of the hotel with the surrounding and architectural context. After, so we have the weighting of the 4 criteria for the 13 historic hotel with the AHP, that is a system that is based on the principle that is possible to establish priorities on an interval scale 1 to 9 among a set of elements of the expression of comparative judgments. And the pairwise comparison between the 13 hotels under study for the 4 criteria are summarized into 4 matrices called the ratio matrices. And to calculate the weight of the 4 criteria relative to the sample buildings under study, we proceeded to normalize the element of the ratio matrices, obtained 4 matrices characterized by the reciprocal property. Si sta per serve un caricabatteria o no? Sì. And after, subsequently, the weight of each individual criterion were calculated for each of the 13 historically hotels. Finally, we proceeded to verify the quality of the weights in terms, thank you very much, in terms of measure the consistency of the ratio matrices, and quality is calculated through the consistency ratio. And in this case, we have that all 4 criteria passed the consistency check. In the third and last phase, we have the application of econometric analysis. And so we adopted a multiple linear regression models. Okay. And so we have that the delta V represent the dependent variable, that is the difference in value between the historic hotel room and the comparable hotel room. And the W, A, B, C, and D define the independent variables consisting of the weights that respectively attributed to the 4 criteria: historical and artistic importance, architect, conservation of the original appearance, and cultural importance, that obtained with the AHP. And observed the p-value and the t-student, we have that the variables A and B, so historical and artistic importance and architect, are not significant, so they are not able to explain this difference of value between the value of hotel historic room and hotel comparable room. And maybe the variable C and D, conservation of original appearance and cultural importance, resulted significant and able to explain this delta V, that is the variable dependent. So for the variable C, conservation of original appearance, we have a direct and positive relationship with the dependent variable. So if C increases by the 10%, we have that the variable dependent increases by the 4.4%. That is meaning that the conservation of the original appearance of the historic hotel contributes positively to its value. For the variable D, we have an inverse and negative relationship with, so if D increases by 10%, we have that the value, the difference value with historic hotel room and comparable hotel room decreases by 5.1%, and that is meaning that an increase in the integration of the historic hotel with the surrounding cultural context result in a decrease in value between the historic hotel and the comparable hotel. In conclusions, we have that the value of the historic hotel does not derive so much from their historical and artistically importance or from the architect signature and prestige, but it's rather from the conservation of their original architectural features and from their relationship with the surrounding and cultural context. Future developments, it's maybe to extend the survey to various territorial contexts, maybe to Florence or Naples. Thank you very much for your attention.
Thank you very much.
Thank you very much.
Are there any questions from the public?
A curiosity.
Yeah.
Yes.
Why do you integrate the three different processes in order to define the value of this different sample of the hotels?
Why the integration between AHP and model linear regression? Because with the AHP we can capture the extrinsic characteristics, the value of extrinsic characteristics. So the marginal price of the extrinsic characteristics, and for the intrinsic characteristic, we adopted a linear regression model for both extrinsic and intrinsic characteristics. Thank you very much.
Any other questions or comments?
Thank you very much.
Thank you very much.
Questo non lo so, è tuo? Sì, è tuo.
Okay. So we are almost concluding our session, and we have time for the last presentation by Professor Sergio Copiello, Carlo Grilenzoni, and Pietro Bonifaci. The title of the presentation is Marginal Cost of Buildings Energy Retrofit. I leave the floor to Professor Copiello.
Thank you very much. Maybe you can help me with the... Oh, I found it. Okay. And about sharing this one.
First, we take it to the slideshow.
Okay, so this one.
Yes. Now we can share. Now you can share. Window. This one.
Okay, thank you very much. So, good morning. My name is Sergio Copiello, and the study I'm going to present marginal cost of building energy retrofit is essentially, let me say, the last leg of almost 10-year-long research I've been involved with my colleagues. The research topic is building energy efficiency. And specifically, we are interested in analyzing the economic implications of building energy efficiency. Meaning that for us, there are two main issues. The first one is whether or not high-performing buildings command a so-called price premium. So they are sold for a higher price. And the second issue is whether or not high-performing buildings should be expected to incur in a sort of cost premium. So if we should expect to spend more where we are building high-performance buildings, or when we are refurbishing outdated buildings into high-performing ones. There is a problem with these two research questions. There is an issue. The fact is that the first issue has been dealt with by the literature much more than the second one. During the last couple of decades, plenty of study dealt with the estimation of the potential price premium. And now we can find dozens and dozens of studies about this topic. This is just an excerpt from one of our previous study with a literature review. You can see we found almost 50 studies dealing with the estimation using regression techniques of the potential price premiums. 50 studies only about residential buildings, because if we include commercial buildings, then we go up to nearly 100 referred studies. Okay. Not only this issue has been intensely investigated, but also the results are essentially converging. Almost all of the review studies state that there is actually a price premium, and it is remarkable. It is apparent, evident. Obviously, there are differences depending on the kind of method that is used in the study. The previous studies was essentially based on traditional hedonic price models, while the latest ones make more often use of SAR and SEM model, meaning spatial autoregressive models and spatial error models. But anyway, there is a considerable convergence toward the occurrence of this kind of price premium. On the other hand, there are essentially only few studies dealing with the estimation of the potential cost premium. We know that we should expect a cost premium because when we push forward energy performance, then we are using more building material, more advanced building material and systems. So it can be expected that in order to lower the operating energy and the operating cost of our buildings, we need to use more embodied energy, and so we need to expect higher investment costs. But still, there are just few data about this topic. So, since we dealt with this topic almost 10 years ago, based on previous studies, we wanted to add some figure to the available ones, and also to compare the new results with the previous one. We essentially aiming to improve a bit the knowledge on what is happening on the cost side by estimating the marginal cost related to several improvements to be carried out on a few buildings. So we went on with the estimation of the marginal cost. Marginal cost is fundamental part of the microeconomic theory, especially when it comes to the identification of the optimal firm behavior and choice. We know that according to microeconomic theory, it is worthwhile to expand production until the marginal cost is lower than the marginal benefit. So we can quite easily and straightforwardly translate this concept, this notion, into the estimation of marginal cost for building energy efficiency, meaning that it is worthwhile to push forward energy efficiency, to go on with retrofitting actions until the marginal costs are lower than the marginal benefit. So we are going to consider several improvement actions. We are going to estimate the difference in total cost related to these actions, and also the difference in the underlying energy performance of our building. So we can estimate a series of marginal costs. We did that on 3 case studies. They are all detached houses located in the Veneto regions, in the outskirts of a small size town in between the provinces of Padua and Venice. The buildings are located in the E climate zone. They were all built between the early 60s and the early 70s, and in this slide you can also see some basic data about the gross floor area and the heating volume. Here are also another excerpt from the project documents for these buildings, and especially you can see the 5 retrofit measures that we tested subsequently. So we started with the replacement of the boiler with a new condensation one. Then we went on with the insulation of the walls. After that, we tested, again, incrementally the replacement of the rule and putting also an insulation layer on it. After that, the installation of thermal break frames and triple glazed windows, so the replacement of frames and windows, and finally the installation of solar photovoltaic panels. Here is it's a bit difficult to see, but then there is a diagram that is much more meaningful in my opinion. Here you see anyway all the data we gather about the additional investment cost, and then the energy performance index, so we can identify the changes in the energy performance index. You see that in the third column, the so-called performance gain, the corresponding energy rating band. So you can see that by adding, by going on with additional retrofit action, we were able to move the 3 case studies from the G rating band to the C or D energy rating band, and associated to them the related marginal cost. Here is the diagram I was talking earlier, and on the right side with the blue dots, you can see the data that was in the previous table. So our latest estimates about the marginal cost for this retrofit action. You can see also the trend line, the fitting curve, which closely resembles what is the expected shape for the marginal cost curve. But in this diagram, you see also with the orange dots the previous estimates. The orange one are the data points we estimated in 2015 based on an EU-funded project carried out between 2007 and 2009. And you can see that there is essentially a huge gap between the latest estimate and the previous one, meaning that with the latest data, if you want to really push forward, push really high the energy performance, you need to expect much higher marginal cost. So we went on asking ourselves why there is this kind of gap. And we came out with essentially 3 potential explanations. 2 of them we were able to test. The first one, I guess it may be obvious, it may be an objection, you can say, and the fact is that in this diagram, we are comparing data estimated in 2024 with data coming from 2009. So we can easily expect that the first reason for that huge gap is the change that usually occur for building costs over time. Building costs are expected to grow over time, and during the last few years we also saw that there were huge increases in the cost for several building materials due to the COVID pandemic first, and then the war in Ukraine later. And so this was our first possible explanation. But a bit of a spoiler, we also need to come out with additional explanation, because this is not the main reason. The main reason, turns out, is because not only costs change over time, but also methods change over time. And in particular, there has been a considerable shift in the method used in order to identify building performance. Here you see the effects. With the green line close to the orange one, you see the effect of the changes in cost. So it is noticeable, but it is not the main reason. With the light blue line here in the middle, you see the effect of the change in the method used in order to estimate building energy performance. The previous method was based just on the ratio between surface and heating volume. Now we are using a method, the so-called reference building method, that has been criticized for several reasons, and the change in the method is our main explanation. Still, you can see there is a gap between the light blue line and the green line. We have a third explanation. We think it may depend on the fact that we are comparing, yes, residential building, but there are some differences in the building typology. We consider just detached house, while the previous data was referring to multifamily buildings. So there are some differences in the building materials, in the construction here, and we are trying to figure out how to test for this potential additional explanation. So I'm running late, but I already told about the conclusions, the provisional conclusion of our studies, and thank you for your patience, your attention.
Thank you very much for your interesting presentation. If are there any questions from the public?
A curiosity also, another curiosity from me.
Yes.
No, it's really interesting, the comparison of the result, because it is essential to understand which way the different buildings, considering the renovation
Yes.
with a purpose of efficiency, could improve the quality, but also to improve also the cost that could be managed. So starting from your consideration, do you think that we can define some guideline in order to manage the construction building and improve also the quality of management of construction?
Yes, well, the first consideration was about the change in method. So we are facing data that, in our opinion, are not so stable. The change in the method is essentially meaning that we are raising the bar too high in order to really be able to arrive to, let's say, the B rating band for the already built buildings, so for outdated building. But what we can see, even with the new method from the marginal cost curve, is that it is somehow easy to arrive to a middle rating band, let's say a C rating or a D rating, even just with a few small, if you will, retrofit action. So just changing the frames and the windows or replacing the boiler with a new one are retrofit action that are able to provide you with a considerable increase in performance, meaning also in the value of the building, without incurring so much high cost. So it is something we should think about. So meaning maybe we should not think about bringing all our outdated building to the A or B energy rating band. We can invest less, obtain less, but still it will be a considerable improvement, a considerable result. Maybe this is something to think about.
Thank you.
You're welcome.
Thank you very much. Are there any other questions?
More like a curiosity. It was very nice presentation, very consistent. Also the way you try to, let's say, demonstrate the assumption coming out from the results. Going back to the costs, you talked about price premium and cost premium. I was wondering if you tried to replicate the same analysis with the price premium as well.
Oh, actually, we are coming to there because we dealt with the price premium in several previous studies. So for the next step, we would like to match the results for the cost premium and the results for the price premium. But first, we think we need to explain the difference because actually there is this problem. We already tried a comparison a few years ago, and we found that the marginal benefit curve was crossing the marginal cost curve at around, let's say, between an energy performance index of 80 and 50. With the new data, we found that the crossing point is below 100, higher than 150 as the energy performance index. So there is this huge gap that need to explain. So it may be useful to go on with this kind of comparison, but we also need to explain if there is some kind of tricks in our data we need to consider. Okay.
Thank you very much. Any other questions? Okay.
Thank you.
Thank you.
Thank you.
Okay. So we can close this session that was very interesting and rich in topics, different topics, multi-criteria analysis, health, and main challenges cities are affording now in our time. And I think that it could be a good opportunity to find a link between these different research in order to cooperate each other, in order to boost some cross-cutting disciplines and advance in this type of research. So we can finish our session. Don't lose the second session of EMEWE at 2 o'clock. That is the second session of the day that will be chaired by Professor Maria Cerreta. And thank you for being here, and have a nice ICCSA conference. Bye.
Thank you.
Thank you.
Thank you.